Hello, this is the Tessellation's Honors Project Part 3. This part of the Honors Project is based off Marcus Cornelius Escher's work. He was a graphic artist who lived from 1898 to 1972, and throughout his career he developed a passion for creating tessellations of recognizable figures. He used a number of techniques to accomplish this task. For this part of your project, begin with researching the techniques that M.C. Escher used to create his intricate designs, and then using your geometry software, apply one of Escher's techniques to create your own Escherlike tessellation. Use color to make your tessellation more visually clear and appealing. Submit the file containing your tessellation. In the space provided below, explain the transformations you use to create the tessellation. So research M.C. Escher and what he did and how he did it. Look at some of the stuff he did. It's really cool to look at. And then create your own and explain it. And make sure you submit the file that you created, which makes it easier for your teacher to grade. Tips for this: use the websites as part of your research that are listed in the lesson. Use GeoGebra for your tessellation. No other programs will be accepted. If you use any other program, it will not be graded. GeoGebra can be found in the Unit 1 Lesson 1 lesson resources. And then tips on how to use it are in every GeoGebra activity. Every lesson has one. And there's also a GeoGebra Basics video that you can watch to get you started. Grading. This final part is worth 40 points. 20 points for correctly using transformations to create a more complex tessellation, 10 for using color patterns in the tessellation, and 10 for providing an accurate and thorough explanations of the steps taken to create your tessellation. So half fit for the tessellation, 10 for actually using color to make it interesting, and 10 for explaining what you did. So here's the model example. In this example, they start out with a square in the upper left corner of the screen. And then they found the intersection of the diagonals to find the center of the square. And then they just do a kind of funny zigzag line about from point B to E, the center. And then they rotated the zigzag line 90 degrees around point E 3 times, so that it would all the way around the square. And then they drew vectors V and U, which are the width and length of the square, and then they translated the square over and over. And then they translated the rows, and then hit the outlines of the squares, and only highlighted the extra parts. So this is actually just squares, but they created polygons on top of these points of these regular shapes that the zigzag lines created. And then they alternated those colors so you could see the pattern. This is one of the techniques Escher used to create tessellations. So to create one like M.C. Escher's, create a polygon that can be used to tessellate. By this point, you know which ones do and which ones don't. Parallelogram, square, equilateral, triangle. Make a design in the polygon that has rotational symmetry, that you can rotate around the polygon. A great way to do this is to locate the center and then rotate the design elements. And make sure they all stay in the square. Once you have that, use the vector translations to generate an entire row and then translate the row. And then go in and highlight your figures and get rid of and hide the squares. There's other examples here. There's ones on YouTube, 6th grade math examples. There's ones in Spanish. And then there's general translation instructions in GeoGebra. So if you need these in a different spot, let your teacher know, and we can make sure you get these sites. These are great examples, great tools for you to use. If you have any other questions, please don't hesitate to reach out to your teacher. Your teachers are all here to help. We're all here to help you succeed and have fun with this honors project. Good luck!